Hi, this is one of a few screencasts that will help you to review for the quiz that you'll be having this week. So this screencast is going to review just the general idea of forces as well as one of the key formulas. The screencast that will be posted after this will be focusing on the idea of work and some calculations involving that. And the third main screencast you should be reviewing for the quiz is the one that was posted just this past week on mechanical advantage. So when you're studying for the quiz this week, definitely look at the three screencasts I just mentioned. Also refer to the textbook and the pages I'll also give you in the screencasts. And the final source of information when you're reviewing for the quiz are your class notes. Okay, and so please feel free to watch these as many times as you need to master the material. Now, this information for this screencast is taken from couple pages in your textbook. So this is actually mainly from page 98 to 100 in your textbooks. You can definitely follow along and review from there as well. Now, the first definition that is up here already is force. Now, what is a force? A very simple way of thinking about it is a force is a push or pull that acts on an object. Now, there's actually two main categories of forces. Now, one is, we're going to call them contact force, and the other one is, as you probably have remembered, is action at a distance. Now, for a contact force, that basically is a force that results from actual contact or physical contact between the force itself and the object. An example of that could be friction. For example, if you're riding your bike on the ground and you suddenly hit a patch of ice, well then the friction between the bike and the ice is decreased, okay? And so as a result of that decreased friction, your bike's going to slip around a bit, okay? But that force still results from actual contact between your bike wheel and the ice itself. Now the second category of forces are action at a distance forces. Now, this means basically the action of the force happens, as the name implies, at a distance. So there isn't necessarily, or there isn't, an actual physical contact between the force and the actual object. An example of that would be gravity. So if you were to suddenly drop your pencil, um, it will still fall to the ground or be pulled to the ground, even though there's no physical contact between your pencil and the ground while it's falling. Now, this is one main kind of definition that we looked at, but another kind of area of review is this concept of mass versus weight. And your textbook goes into a lot of good detail over these two concepts. Now, what are the differences between these two? Now, for mass, the textbook tells you, I'm going to use short form, mass is the amounts of, or AMT, of matter. Okay? Another way of describing this is how much stuff there is in an object. Okay? And the mass also doesn't change. Okay? So if an object has a mass of 5 kilograms on Earth, well, when that same mass goes to the moon or goes to the sun or goes to Jupiter, it's still going to have a mass of 5 kilograms. The amount of stuff inside it will still be the same. Okay? And the final piece of information is mass is measured typically in kilograms. Of course, you can use grams as well, but the standard measurement is in kilograms. Okay? Now let's compare that to weight. Now weight is a little bit different. Weight is the amount, AMT, of force on an object due to gravity. Okay? So the key difference is it's the amount of force on an object due to gravity. So it follows that if there's more gravity, there's going to be more weight. If there's less gravity, there's going to be less weight. So what that means is it can change. The weight can change. Now, if I, well, here on Earth, I weigh, let's just say 70 kilograms here on Earth. in order to go to the moon, okay, my mass doesn't change. I'm still 70 kilograms in mass, but my weight will change. And if you've ever seen images of astronauts, they look like they're kind of floating around on the moon. It's not suddenly that they've lost a lot of mass, they're suddenly smaller, okay? But because the gravity on the moon is less, well, then that explains your observations of them seeming to kind of float around or jump higher on the moon or in space. Okay? And weight is measured in N, which is short for, right, newtons. Okay? So we use N as a short form. Now, an easier way of kind of remembering this relationship could be, hopefully you can see this, is mass, weight. So relationship is when a certain force of gravity acts on a mass. Well, then that's what results in the weight. Okay? So let me go back to my yellow here. All right. Now let's do some calculations. A key formula here is F equals mg. Okay? A very important formula here, and that's the one we'll focus on for this screencast. So let me do some labeling here. F stands for force, and that's measured in newtons. M stands for mass, and we measure that in kilograms. Be careful. Okay? If the question gives you information in grams, well, you should convert it to kilograms when you're using it in this formula. Okay? And G stands for the gravity where it's acting on. Okay? And this is measured in newtons per kilogram. Okay? Now, if it's on Earth, and a lot of the calculations will involve gravity on Earth, well then that's going to be 9.8 newtons per kilogram on Earth. Okay, so let's put a box around this one. F equals mg. That's the one we're really focusing on. Now let's go back to yellow. Let me show you a few sample calculations. Okay, so let's write it down here. Example number 1. Okay, if, for example, let's say, find weight of an object that is, let's say the object is 2 kilograms. Actually, let's just make it a little simpler. Let's go back a little bit. Okay, so let's see here. Oops, my mistake. Okay, let's say we're going to find weight. What do we know? We know the mass is 2 kilograms. We also know that it's going to be on Earth. Okay, so I can word this in a number of ways. I could say, what is the weight of an object that has a mass of 2 kilograms on Earth? Okay. Now you'd have to use a formula. So the first step I want you to do is to write the formula down. F equals mg. Now, let's put in brackets. Another word for force is weight. Okay, so these two are also very closely related. So if I say find the weight of something, it's basically asking you to find the force. Okay, so write down the formula, plug in what I know. Do I know the mass of the object? I do. It's 2. And I'm also good because this is already in kilograms, so I'm in great shape. Okay. Now what is G? G stands for gravity. Okay. And I know this calculation is taking place on Earth, so I'm going to multiply this by 9.8. Okay. And then when I do that, so let me take out my calculator. Now let me just do it by hand. So it's going to be, I believe, 19.6. Yep, 19.6. And since we're on force, you have to add the units, which is newtons. So the weight of that object is 19.6 newtons. Now let's take another example. Example number 2. Okay. Now let's say, let me see. the weight of the object, let's say, is, let me see, 1469 newtons. Let's say the mass of that same object is 65 kilograms. Say find gravity. So I could word this question saying, okay, there's an object on a mysterious planet. Okay, you don't know the gravity or the force of gravity on this planet, but you do know that the object has a mass of 65 kilograms right here. And you also know that the weight of the object is 1469 newtons. So let's try and find the gravity. So F equals mg, the formula we have. Do I know the force or the weight? Yeah, I do. It's 1469. Do I know the mass of it? Yep, I do. 65 kilograms. Do I know the gravity? No, I don't. Okay. So to find the gravity, a little bit of algebra. I'm going to move this over, so 65 is going to come over on this side. So I have 1469 divided by 65. And then what I'm going to get, I'm going to put it up here. The force of gravity is equal to, oh, I'm going to need to get my calculator out, so give me 1 second. There you go. So I got 1469 divided by 65 equals 22.6. So what I got is, right here, 22.6, and the units is newtons per kilogram is the force of gravity. Hopefully you can see that G that's cut off there. So hopefully this gives you a basic review of how to calculate force or mass or gravity. Okay? And of course, if there's any other questions, you're unsure of anything, please see me. And please also refer to these pages in your textbook as well. Now, if you want to double check if you have completed the homework or for some extra review, the homework questions you did work on was page 102, questions 1 to 3. You also worked on page 105, questions 1 to 8.